Hello one and all, and welcome to the Math Magic Show. Please leave a like and subscribe. As usual, please do remember that usually I post videos on hardcore math topics, but today we're going to talk about a wave and some related concepts to waves. So I'm using a simulation from the University of Colorado called Wave on a String 1.1.21, and let's take a look. So across the top we have some features like manual, oscillate, and pulse. To keep things kind of organized and neat, I'm going to go with oscillate, and let's see what that means. So this starts oscillating. It's basically like a piston that you can see that moves up and down, and so on. What we are going to do is just slow this down so it's perhaps a bit easier to understand. So let's take a look. Down over here where it says slow motion, you click on slow motion. Okay, that's much better. And also here, the right end is, as you can see, clamped. So we're going to just loosen that. So up here, up our right hand corner, just select loose end. Say no end. So it just goes on forever out the window there. When you first encounter something like this, you might just be looking at something that kind of feels random to you, with no structure to it. But is that really the case? And the answer is no, of course. So take a look. First of all, look at this little black dot on the wheel. Keep an eye on it as it spins. So, for example, beginning from the top, that's one cycle that it does. Again, look carefully from the top. That's one cycle that it does. You see that? So one spin of the little black dot on the wheel there, it represents one cycle. Now there's a deep connection to waves from cycles, which is this one, because you see this little string of beads is attached to that wheel. As the wheel turns, the piston goes up and down. So look carefully, this is a key observation here. Across the bottom it says frequency. The frequency is in hertz. So a hertz is 1 cycle per second. That's the definition of a hertz. Now that cycle, you can imagine, basically is the following. I'm going to put this down to 1 hertz, and let's just focus on 1 hertz. So this is 1 hertz, 1 cycle per second. So what that means is the following. That little black dot, beginning, say, from the bottom, takes 1 second to come back to the bottom. Now this will take perhaps a little bit longer because I'm doing it in slow motion. Otherwise it would seem too fast. But this is what it would be like in real time. Take a look. You see? This is 1 second. It's hard to kind of keep an eye on the black dot, but I think you can still do it from the top around, from the top around, from the top around. So the piston takes 1 second to go from its lowest point to the equilibrium, which is kind of like the middle, to the highest point, through the equilibrium, back to the lowest point. That's the way to think about it. Okay, let me go back to slow motion though. The next stage is this. Take a look. Over here you see something that says rulers, timer, reference line. So I'm going to put the rulers on. Let's observe something here. Now, our little circle there, little dot, takes 1 second to complete 1 cycle. So take a look. This quantity right here, look carefully. You see that where it goes, that little dot? I'm going to move the ruler up, say, from 2, measure from 2. You see? That green dot up to here and then back down. So that is the amplitude. That is how far that little green dot, for example, rises above the equilibrium position, which is in this case indicated with that brownish dashed line. So down across the bottom, you see where it says amplitude? Make that say 1 centimeter like this. Okay, let's maybe move this over. Like a little too much. Make it 1 centimeter. This is a 1 centimeter amplitude. So that tells you over here is, look, it goes up to 3 centimeters. And go 1 centimeter, 2 centimeters equilibrium, 3 centimeters up, back down to 1 centimeter. So it varies by 1 centimeter in the vertical direction there, that little green dot. Another important thing about waves is the following. As you do this, you should observe that there's no actual, like, the beads are not moving left and right, even though it may seem like it, but that's not the case. How do I know that? Because imagine I take my ruler and I place it right here next to this green bead, just for emphasis. Look carefully. You see how that green bead executes just up and down motion only? It's not going left and right. It just traces the edge of the ruler. So when a wave is being propagated, if you just focus, for example, on just one bead, up and down, for any other one it would be like that. Okay, even choose a red bead. It doesn't really matter. Here, a red bead, look. If you keep your eye on it, you see that it basically travels just along the edge of the ruler. And that is it. And it takes that red bead that's traveling along the edge of the ruler here 1 second to go to its lowest point, go to its highest point, and come back to its lowest point. So what is that telling us? It's telling us that there's a deep connection. Over here, the black dot on the circle takes 1 second and slowed down version takes 1 second to complete a cycle once around the circle. It tells us as a result that, for example, a bead on a string of beads also then takes 1 second to go from its highest point to its lowest point and back up to its highest point. That's a cycle for each bead also. It's kind of interesting, I think. And what we're going to do also is the following. Take a look. I'm going to freeze this for a second, just so when the green... stop right there. That's good enough. Let's define something else here. So you see that frequency, which is 1 hertz, in other words 1 cycle per second, that involves time, correct? You have the number of cycles over seconds. You can describe that fact by saying that there's a temporal period, a period in time. It's one that you observe on your watch, right? You watch the little dials on your watch turn, turn, turn. So we call it the temporal period, the amount of time required to complete a cycle. Now here there's a pretty cool feature. Take a look down below that says timer. You can enable that. I think this timer can even be moved around the screen to different places. So I'm going to put it over here just so you can keep track of things easily. Okay, so let's go through this in slow down motion. Take a look. So let's see. I'm going to hit it when it goes to the bottom as low as possible. And look, it went there. And I have to kind of do this just look. Okay, well, you get the idea, right? Look, okay. Lowest point, back to highest point, back to lowest point. I'm doing it by hand, so it's a little bit rough, but it should be about 1 second to complete 1 cycle. Maybe it might be better if I do it over here. Let's take a look. So from the lowest point. Let me reset it. There it goes. Look. You see? Look, 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 look. Okay, so that's 0.96. In other words, about 1 second, as I said. That also means that any bead here will take 1 second. So let me just... let a bead move along the edge of the ruler and look carefully. Okay, I'm going to do it from the equilibrium position, bottom, top, and then back to equilibrium. And you see it's 1.99, and again, that's about 1 second more, right? Let me zero this out. Choose some other random bead over here. Let's see here. Some other random, this bead right here. Okay, and we'll do it from equilibrium position. So when it goes through, there it goes, look. It goes there, and then stop. 0.99, about 1 second. So as I said, there's a deep connection between that piston motion and the oscillation of the bead in a vertical line, and it takes 1 second for each bead to execute its own little cycle in its own little vertical line. There's something else, and I'm going to do that by freezing this at just the right place. There. Okay, that's kind of okay. It's not the best, but okay, that's perfect. Let's take a look at something here. Now, even though we're just kind of estimating things, I hope you can tell there's another concept involved here. Roughly speaking, there's also the concept of period and space. When you have a wave like this, you take basically a picture. That means you freeze it. It's not moving anymore. And now you can define the concept of what is sometimes called a spatial period. In other words, how much space it takes for a cycle to complete. Now you have to decide what you mean by a cycle. So in this case, what I mean by a cycle is the following. From this place right here, right above my head, that one, up to the top, so about that position, and then back to the trough, and then finally back to right here, to that green bead. In other words, to the best of our ability, we kind of are estimating one wave as this. So that's 1 cycle. Now, in this case, you can measure it. Take a look. You see, it's about 6 centimeters. That would be the spatial period. Period in space. And you get that by taking like a picture basically of your wave and then measuring with a ruler, just like I'm doing, to see how long in terms of space it takes for a cycle to complete. Now this isn't exactly perfect because, as you can see, on the bottom there's a feature called damping. What the damping does is it kind of stabilizes the oscillation. So in other words, the oscillation might be kind of big, close to the piston, but then over here, close to the window, the oscillation begins to get dampened and dies away. So what I'm going to do is remove the damping completely. Take a look. So just make the slider equal to 0 and let this run a little bit. So let's see here. Let it go in slow motion. And then, as you can see, the wave becomes very nicely balanced. And I'm going to freeze it. That's perfect. And now, take a look. So this is from here, as you can see, it's about 6 point something centimeters. That would be the wavelength. The amplitude you can measure with a ruler So basically from 2 to 3, so that's about 1 centimeter in amplitude. And every single bead here takes 1 second to complete its own cycle. A common question after this is what happens when you increase the frequency. So down below, what I'm going to do is I'm going to change that setting a little bit. So I'm going to set that at 2 Hertz. Now 2 Hertz means 2 cycles per second. And I'm going to let this run for a little bit, kind of get really neat, stabilize at that new frequency. Whoa! Okay, so 2 cycles per second. Okay, freeze that in time a little bit, advance it a tiny amount. So this is a little bit different. So here, what is true is that the motion of any particular bead always is up and down. It doesn't go left or right. The only difference is now, as you can see, it takes the wave from 0 centimeters to only about 3 centimeters to complete 1 cycle. In other words, because our frequency is 2 Hertz, that means 2 cycles per 1 second. So let's see here. It doesn't really matter where you begin to measure the cycles. In other words, all that really matters is if you begin measuring where this dot is located, right there, just make sure it comes back to the same spot, and that gives you a cycle. It doesn't matter where you begin, but just make sure you come back to the same spot. That's the key to 1 cycle, to understanding how to measure it. So I'm going to clear my timer here, and let's observe what happens here, okay, to the best of my ability. Okay, I stopped. So that took, as you can see, about half a second for 1 cycle to complete. So that's telling us something really important, which is this. That as the frequency increases, the period, which is the time for 1 cycle, decreases. Let's do this one more time. It gets kind of tricky to do it, for example, at 2, 3, 4, 5 Hertz and so on, because it's really hard to time everything perfectly. But that's such a general concept. As the frequency increases, then basically the period decreases. And remember, the frequency is cycles per second, correct? So that if you say 2 cycles per second, then if you flip that number, that's all you really need to do. One more time, if you just flip the frequency, so instead of saying 2 cycles per second, you say 1 second per 2 cycles. You see that? Then you can do 1 over 2, which is 0.5, which is equivalent to saying half a second per 1 cycle. So the frequency, read the right way, is both the frequency and the period. As long as you just flip that fraction for the frequency. These are interesting little things. Okay, and that is it for me. Thank you so much for watching. I hope this has shown you something interesting. Please leave a like and subscribe. And I will see you in another magical video.